Here's the PLC to show the interrupt for the circuit trainer. Go over to the circuit trainer. When Andrew clicks the button, it will pause for 5 seconds, and then it'll start going again.
So this is the 8051 assembly code. It does a 2x2 matrix multiplication. So I loaded numbers into the registers 0 through 7. Just use those as the 8 input data. The first section here does the matrix multiplication. That's the second set of matrix multiplication, moving the registers into place using the multiply and addition. And then it does a summation of the matrices, the intermediate sum, and then the final sum. Here's it running. And it'll populate in the data memory. I just organized it to see each number of the matrices as it is calculated.
And then over here we have the logism circuit. So right here, this section is going to be performing the I'll start that, and then it's going to cycle through all 4 of our cores, but for simplicity we're just going to focus on this top one. When that green bar is lit, the left side is what's going to be using this section here. When it ticks around, there's that. And then if I come over here to our shared memory bank over here, we have 2 registers that can be displayed. There are 16 within the functional block there. If I come up to here, we are currently writing to the first one, which is being viewed by both of them. If I switch over to writing to the second one and set our second visual to that as well, we are now writing to the bottom one, and only the bottom one will be updating. I also have the ability up here to flush it, wiping everything out, and since we never changed our write address right there, it's going to continue to write to that memory location there. This component here is going to be looking at the vector registers. So the current instruction we have right here under our opcode is the addition instruction. To make up our vectors, we have 4 16-bit sections that are being combined into one 64-bit. From all the little tunnels you can see there, we have the different components of each of the vectors. The output for this instance is being displayed up on the top here. So we're going to be splitting up these top 4 X displays, and that's one of our vectors. And then the bottom 4 down here is going to be the second one. Adding those 2 together nets this up here, a bit of a mess. We also have the ability to switch it over and perform subtraction. So same setup and everything, just with the subtraction result placed up top here. This is the result for the multiplication, and we can also switch it over and do the division. If we switch this over to our dot product instruction, it only requires one of the displays here because we're not doing as much numerical output. I'm just going to have the 2 since everything is summed together, and that would be the dot product of all 4 of these components together. And then rounding out the end of our functions for the vector math, we have the neuron transfer function opcode put in. And this top register here relates to the first one, and down here relates to the second one. Right here is a quick view of how the shared memory is functioning. And then this section overviews the vector register arithmetic. Got all the individual functions here, and we have an encode mux as well as decode section, and that is what determines our 4 outputs.